fashion. He's promised to tell us about how the 64-bit migration went of their product, SimCorp Dimension. So welcome, Stig.
Thank you. When I was first asked to do this presentation, I was thinking about how boring a presentation I got out to make in such a forum. There isn't that much in it. It's more or less plug and play. However, I realized that we spent some few hundred hours doing this, so of course there's a little into it anyway. So this is what I'm going to present to you, the various things we had to do to get this up and running. And of course a little about why. And so first I will do a short presentation on the company and our product. And then why did we do this 64-bit migration, the considerations to do before jumping into doing this. And the main thing was actually the challenges regarding space consumption. And what needs to be changed. So what did we actually do? What kind of parts of the code needed to be revisited? Especially coordinate functions, of course. And then I will end up with a summary and Q&A, but you're more than welcome to ask during the presentation. Yeah, SimCorp is a Danish company founded back in 71. We are worldwide represented in all these countries currently, where we have customers and offices. The main development is done in Copenhagen, but we have some in Ukraine, UK, and Germany, where they do some development as well. It's an investment management system that covers all aspects of this. I'm a computer guy. I don't know much about what the system actually are capable of, but so please don't ask questions when it's economics. We have a little more than 1,100 employees worldwide. And the system is mainly developed in APL, but also some C# code is used, especially in the front office part of the system is made in C#. We are about 300 developers. We have currently more than 65,000 functions with 1.6 million lines of APL code. No comments and blank. And we have a little more than 1 million lines of C# code. But still, I will say this is how the system looks like. The main part of SimCorp Dimension is still based on APL code. And the C# part is mainly to do this fancy graphics. And of course, we hope that it will do it a bit faster too. Well, why did we choose to get into this 64-bit? And the main reason, and maybe the only reason, is it's all about address space. We came from a 32-bit world running on 32-bit machines. We had approximately 1 gigabyte of workspace available. Running on 64-bit machines, we could double that, but still the customers were not satisfied. They wanted bigger workspaces, so they got it. Now the sky is the limit. I will not quote Bill Gates for what he did not say about 640 kilobytes, but I will still claim that this should be enough for the next few years or maybe decade. So, all fine. Actually, the maturity of the 64-bit platform is here. It's mainstream. On server side, we only have 64-bit almost. Yeah, again, it really hurts. It's 4 gig limit where we cannot use all the 4 gigs. And there could be some business reasons to do so. It's just a normal or obvious step to take now the technology is here. Why not just follow the mainstream? This is probably the most used illustration in PowerPoint shows worldwide, I guess. But still good. And of course, before jumping into this, we had to make sure that the customers actually do have the hardware, actually are prepared to do additional investments, because having lots of address space it's fine, but if you have to swap it to disk, it's not fine. So you need some more RAM to actually have the physical memory available and not just in virtual matters. So our customers have been screaming for more larger workspaces. They have bigger and bigger data volumes to deal with, and they hate seeing this VS full. So now they got it, and then they start complaining about that our application uses a lot of workspace, and hey, don't use it up front. We want all the new workspace for ourselves and not for your applications and data inside the APL workspace. And that is, without question, the most, the biggest problem we faced in connection with this migration project. Just to illustrate this, as you probably know, most of you, data is represented in pockets. And having various properties, length, ref count, pocket type, and then the shape or data depending on rank. So you have, do you have rank 2? You will have 2 of these shapes, and then the data will be there. If it's simple data we are dealing with. These vertical lines I illustrate bytes, so it's 4 bytes wide. And when we go to 64-bit, this is a pocket. We don't get more for this extra space consumption. It's simply just doubled in size. To illustrate further, in the good old days, just assigning a 0 to the variable a gives you 16 bytes of memory consumption. So the pocket takes up 16 bytes. If you give it a shape, vectorize the a, we have to use another 4 bytes to represent this. And of course, not surprisingly, it doubles when we go to 64-bit. And then of course, if the data are more complex, then you don't have the data directly in the pocket. You have pointers to new pockets generated. So all in all, making this 2 times 2 matrix with vectors of simple integers take up quite a lot of workspace. So, what is the problem? In our case, we have about 90,000 of these small pockets, actually just containing a scalar number. We use it as named constants. So, of course, they all doubled in size. And not only data, but of course also function, their kind of data as well, will double in size. So our initial workspace, as you can see, grew from 54 to 81 megabyte, just going from 32 to 64-bit. Well, how hard is it then to actually migrate to Dyalog APL 64-bit? This is just plug and play. Yeah, if you can answer yes to all these 3 questions, you can actually leave the session now or take a nap. There's not more in it. Of course, you can load the old workspace made in 32, and then you're up and running. But not many can answer yes to all these 3 questions. Let's start out with the COM technology. It has been dying for several years. And maybe now it's time to say goodbye. Actually, it is still supported in Dyalog 64-bit, and actually one of the products we used, a charting product called ChartFX, was available in 64-bit, but they had changed the object model quite a bit, so we had to make a huge effort to change to this anyway, so we decided actually to skip the COM part and get rid of this. There are many reasons why not using COM. So, and now Dyalog has given us the possibility of embed .NET controls into the APL GUI. It was obvious to take some of the controls we're already using in the C# applications and reuse this in APL. So we did, of course, a huge project, but we managed to do so. And then there are all the coordinate stuff. Of course, you need 64-bit DLLs, but that is not all. Having access to the 64-bit versions of the DLLs. The first problem we actually bumped into, even though it's more or less theoretical for now, is that we now have 8-byte pointers and not 4-byte pointers. And Dyalog APL has no representation of a 8-byte integer. There's no such thing as a 643 type in the APL, and there will not be. We have the floating point type, and that should be sufficient. But we are not happy to have these pointers return from a DLL function returning a handle or some other pointer type to APL and have it demoted to a floating point, and then should pass it on to another DLL function. And you can imagine what could happen if doing so. There's probably many discussions here and there, and it has been discussed whether it was APL could support a 64-bit integer type, and that's a very good discussion in this paper. The presentations are on the Stig, so if you need the. Yeah, a little bit more about pointer stuff. So this one, this is just an example of a DLL function. It's a common Windows function returning a pointer, which is now a 8-byte pointer. And it works as long as we stay under the 4 gig limit. Otherwise, it will return, if you use U4 as it was declared before. And returning it as a U8. Or actually, one thing is the right side declarations. On the right side, you're actually able to make definitions as structs. So, okay, I make a struct containing 2 U4s, and then we have the upper and the lower part of the D word. But I think that it was not really an option for us. We would like to say if it's a U8, then it's a U8 and nothing else. And this approach is definitely not possible if you have a DLL function returning handles, because you're not able to, on the left-hand side, to declare structs this way. We actually discussed it with Dyalog, whether it was a possible path to follow, but we agreed that it was not. So actually, we found out that the recommendation is to use I8, and it gives you at least the 53 bits of precision. And so, in most cases, it's sufficient, definitely. But in theory, we can, of course, bump into problems, and we don't want to do that. In version 13, a new type of coordinate types is introduced. Actually, unofficially, I think it was present in 12.1 as well. So you had the possibility of assigning the output from a DLL function, returning a handle or pointer type, and keep it in APL and use it to pass on to another DLL function without mangling it, without demoting it to a floating point number. So in this particular case, we have something like a 64-bit integer to deal with. But of course, you cannot manipulate this data pointer. Then it will be demoted to a floating point. But it's used to carry around as input and output from coordinate functions. Is that clear? And currently, we're actually only dealing with 64-bit. As far as I know, still in Windows, so we're not able to address more than what the 44 bits give us. But at some point, this limit will be removed, and then we have the problems. Another thing we bumped into when it comes to coordinate function is about alignment. As an example, we have this definition in 32-bit, and it corresponds. not being 0. Yeah, in the 32-bit world, it was all fine. We could define this as U4, I4, U4, this struct. But in 64-bit, we ended up doing this. Say, hey, there's 5 elements, there are only 3 elements in the struct definition. And actually, this would do too, so you could just say U8 all the way and it will actually work. But this tells us a bit more about what we're actually dealing with. Because before we had this with 4-byte alignment, all the 3 were equally long. And in 64-bit, we have 8-byte alignment and still have a 32-bit D word, and then the 64-bit pointer, and then a 32-bit bool. This is a very simple example and actually not a big deal, but we had, you can probably not see it, and that's not the point. The point here is we have a lot of these functions, and we have to take all of them and look through all the definitions and try and figure out how should we align the structs so they actually fit into the 64-bit world. So the U4 went into the U4, I4, and so forth. And this is an example where we actually use the new P type. We haven't implemented it yet, but it would look like this if we do so in the near future. Just to say that there's a lot of work to do there if you use coordinate functions a lot in your system. Then the probably biggest problem and where we spent most of the time was some of the homemade DLL functions where we used the A type, where we actually built up APL structures in C++ in this case, and pass it on to APL using the library functions delivered by Dyalog to do so. So we build up the structures and pass it to APL, and everything is fine. Typically, and these functions are actually our database interface. So it looks up data in Oracle and then do all the stuff trying to get into APL arrays and then return the data. And usually it's mixed data there. Yeah, integers and strings and all kinds of stuff, and nulls and all this stuff. And as we saw earlier, pockets are doubled in size, so of course the data returned from these functions were doubled too. And as we are actually dealing with lots of data, and they actually didn't have to take up that much space as they actually did, we had to find new ways to deal with this. Maybe this is very specifically for SimCorp Dimension, but nevertheless, you all know that the vector of vectors format is far more compact than the matrix format when you are dealing with mixed data types. So that's what we were doing, and using null indicators instead of passing null values and stuff like that. So we could make it very compressed, the data returned from these C# functions. But all our functions require, they expect matrices to be returned from this function when they collect data, and we couldn't just change all these functions from handling matrices to handle vectors. So we had to raise it as a matrix. And with actually great help from Dyalog, we managed to reduce the footprint is, in one specific case from 164-bit megabyte to 87 by something they implemented in the mix operation. So when we actually put up the vectors into a matrix, it looked through the data and did a lot of reuse. And actually, it's generally implemented. I don't know if you're aware or have seen it, but it's really a nice feature. The data we use to return from this database interface was a number of pockets, basically. And many of these pockets could be the same, but still, if we have this vector with 1 and vector with 1, we will make 2 copies of this. And APL didn't notice, and so okay, you have a lot of pockets actually containing the same data. So what Dyalog actually did was in a data in the range from 0 to 20. So when we're dealing with numbers, they actually reuse the pockets and point to the same pocket. And of course, when you start mangle with it, it will make a copy. But it was actually possible to compact data quite a lot. And we had many data within this when we're dealing with Booleans, of course, ones and zeros. But many of the domain-based data we have was actually in the range of 0 to 20. So you can really see a huge benefit from this compaction algorithm. As I said, we use C# a lot and .NET. Therefore, we use a lot. But as far as I know, recall, we didn't have any issues at all in this migration process. There are, of course, various compilations. When you compile your assemblies, then you can compile it as 64-bit only or agnostic, so it actually works with both 32-bit and 64-bit. Actually, in the very beginning, we had to deal with having both 64-bit and 32-bit environments up and running, but we were only in-house to get our test systems still running, but it was not our plan to deliver both versions. So our customers were told that from this very version you will only go 64-bit. So, but indeed, no problems whatsoever. When it comes to .NET, it was simply plug and play. So, as a summary, the workspace use, and you can of course still ask, so what's the problem? You have all the space in the world. But our customers really complained, as they did when we converted to Unicode, which is very space consuming as well. They run their system on rack boxes in Citrix environments, and it costs quite a few dollars to get some additional RAM, and so yeah, it shouldn't be that big problem, but for our customers it seems to be. So we had to deal with this problem, unless we would have very angry customers in the telephone each day. And then all the coordinate stuff, tedious, but it was to to be done. And we had to get rid of this old SharpFX and use a .NET tool instead. And that is actually all about it. Half an hour. Any questions?
How long did it take you from when you started until you had the 64 version?
We did it over one version, and one version is half a year for us, so it was a half-year project involved 2, 3, 4 people. We spent quite a lot of time on this memory stuff from the database interface. I don't know if you want to see some of this reuse stuff. I have a few examples in APL if you like to see. Yeah.
What do you think going on plan, once you start working with 64-bit workspaces, if you needed to roll back when you first start to deploy it, do you have any?
Yeah, there was no rollback plan. Actually.
You're going to get it done.
Yeah.
Yeah.
When we rolled out the 64-bit, we had to continue there. So there was no rollback plan.
Okay. Well, thank you, Steve.